You think you understand gravity. You learned it in childhood. You feel it right now, pressing you into your seat. Gravity pulls things down. Simple, obvious, settled. You are wrong. Not partially wrong. Not incomplete. Fundamentally mistaken about what you actually know when you say the word gravity. Here is the deception. When you say gravity pulls the apple down, you believe you have explained something. You have explained nothing. You have named your ignorance and called it knowledge. The apple fell before the word existed. The word added no mechanism, no cause, no understanding of how the earth compels the apple's motion without touching it. And here is what you were never told. Newton himself, the man credited with explaining gravity, explicitly declared that he did not know what gravity is. The cause of gravity, he wrote, is what I do not pretend to know. The greatest work of natural philosophy ever produced contains this confession at its heart, yet somehow, in the centuries since, it was forgotten. Worse still, Newton considered his own equations' implications so great an absurdity that no competent thinker should accept them. How does the sun grip the earth across 93 million miles of empty void? Through what? By what mechanism? He had no answer. And what emerged 2 centuries later was not an answer, but a revelation that the question itself was wrong. Gravity is not a pulling force. Let me show you what it actually is. You think you understand gravity. You learned it in childhood. You can feel it right now, pressing you into your chair. You watched apples fall, and teachers nod, and everyone agreed. Gravity pulls things down. Simple, obvious, settled. You are wrong. Not partially wrong. Not incomplete. Fundamentally mistaken about what you actually know when you say the word gravity. Let me show you the deception. A teacher stands before a classroom. She holds a ball at shoulder height. The students watch. She releases her grip. The ball accelerates toward the floor, strikes it, bounces, settles. Gravity, she announces. The students nod, satisfied. They write it in their notebooks. They believe they have learned something. But examine what has actually occurred. The ball moved. This is observation, undeniable, available to anyone with eyes. The ball accelerated toward the earth at a predictable rate. This too is observation. The teacher gave this observation a name, gravity. What has been explained? Nothing. Nothing whatsoever. The phenomenon existed before the naming. The ball would have fallen identically had the word gravity never been invented. The word added no mechanism, no cause, no understanding of how the earth compels the ball's motion without touching it. The teacher labelled her ignorance and called it knowledge. The students inherited that labelled ignorance and believed themselves educated. This is the naming fallacy, and it infects nearly every mind that considers this question. Consider what explanation would actually require. You release a ball. It accelerates toward the earth. To explain this, you would need to describe the mechanism. How does the earth, without any visible connection to the ball, without touching it, without any rope or rod or chain, compel its motion? Through what does this influence travel? What is the medium? What carries the command from earth to ball, saying, "Move toward me"? Can you answer these questions? You cannot. No one you have ever spoken to can answer them. The word gravity does not answer them. It merely silences them. It creates the comfortable illusion that because we have a name, we have an explanation. But a name is not an explanation. A label is not a mechanism. Describing that something happens and explaining why it happens are completely different acts. Here is a test you can apply to any supposed explanation. Can you describe the mechanism by which the cause produces its effect? If you cannot, you have not explained. You have only named. Try it now with gravity. How does the Earth produce acceleration in a distant ball? Through what does the Earth's influence reach the ball? By what process does mass at one location compel motion at another location? Silence. The word gravity offers nothing but silence on these questions. And here is what should truly trouble you. This silence is not a gap in your personal education. It is not something experts know, and you simply have not learned. This silence represents the actual state of human understanding when we speak of gravity as a pulling force. Let me make this vivid. Imagine you encounter a phenomenon never before witnessed. Objects begin floating upward rather than falling. Stones released from your hand drift toward the sky. You are startled, confused, amazed. Then someone announces, "This is levity, the opposite of gravity. Objects are pulled upward by levity." Have they explained anything? Of course not. They have invented a word. The mechanism remains utterly unknown. Levity pulls things up is exactly as empty as gravity pulls things down. Both are names masquerading as explanations. The error most make is conflating familiarity with understanding. Because gravity is constant. Because it operates every moment of every day. Because we learn the word in childhood alongside cat and tree and mother. We cease to notice its strangeness. We stop asking the question that should haunt us. How does this work? But familiarity is not understanding. Constancy is not comprehensibility. The most ubiquitous phenomena often conceal the deepest mysteries. Consider, you trust that the sun will rise tomorrow. You have seen it rise thousands of times. You are familiar with sunrise. But this familiarity does not mean you understand the mechanism by which the Earth rotates, or why it rotates, or what maintains that rotation through the ages. Familiarity and understanding are entirely different. So it is with gravity. You are familiar with falling objects. You have witnessed falling 10,000 times. But this familiarity has told you nothing about how the Earth reaches out through empty space to compel distant objects toward itself. The word gravity has not explained this. The word has only silenced the question. Now, you might object, but surely Newton explained gravity. Did he not give us the laws? Did he not demonstrate that the same principle governs both the apple's fall and the moon's orbit? He did. He gave us mathematical laws of extraordinary precision. But here is what you have not been told, what lies buried beneath centuries of careless teaching. Newton explicitly, repeatedly, emphatically declared that he did not know what gravity is. In his greatest work, Newton wrote plainly, "I have not as yet been able to discover the cause of those properties of gravity from phenomena, and I frame no hypotheses." I frame no hypotheses. The man credited with explaining gravity confessed that he could not explain it at all. This confession lies at the very heart of the Principia Mathematica, yet somehow, in the centuries since, it has been forgotten, replaced by the comfortable fiction that Newton solved the mystery, that we understand what gravity is, that gravity pulls things down constitutes knowledge. It does not. You have been deceived by a word, and now the deception begins to crack. If gravity is merely a name for a mystery, what did Newton actually contribute? What do his equations tell us, if not what gravity is? This distinction between describing behavior and explaining cause is the very foundation of honest inquiry into nature, and it has been lost, buried, forgotten. It is time to recover it. Newton gave the world equations of extraordinary precision. These equations predict the motion of planets for millennia. They explain the tides. They describe the trajectory of every falling stone, every flying arrow, every cannonball arcing toward its target. For 3 centuries, engineers and astronomers have relied upon these equations, and the equations have never failed. For this achievement, Newton is credited with explaining gravity. But he explained nothing of the kind. He provided a map of matchless accuracy. He could not describe the territory itself. Consider a sailor who predicts tomorrow's tides. He consults tables compiled from centuries of observation, correlating lunar position with water level. He makes his prediction. Tomorrow arrives. The tides rise and fall exactly as he foretold. Has this sailor explained the tides? He has not. He has recognized a pattern and exploited it. He knows that the moon's position correlates with tidal heights. He does not know why. He cannot describe the mechanism by which the moon, 250,000 miles away, compels the waters of the earth to rise and fall. His tables work perfectly. His understanding is nil. This is precisely Newton's position with respect to gravity. Newton discovered the mathematical relationship governing gravitational effects. Every particle of matter attracts every other particle with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. This relationship holds with extraordinary precision. It predicts the orbits of planets, the paths of comets, the fall of objects on Earth's surface. But the relationship describes how gravitational effects behave mathematically. It does not explain why masses attract, or through what this attraction operates, or by what mechanism one object influences another across the void. The equations are a map. They capture patterns with precision, but the map is not the territory. Here is what Newton himself wrote in the General Scholium, the philosophical conclusion to his masterwork. I have not as yet been able to discover the cause of those properties of gravity from phenomena, and I frame no hypotheses, for whatever is not deduced from the phenomena is to be called a hypothesis, and hypotheses, whether metaphysical or physical, whether of occult qualities or mechanical, have no place in experimental philosophy. Read that again. The author of the greatest work of natural philosophy ever produced openly declares, I do not know the cause. I refuse to speculate about it. Whatever cannot be demonstrated from observation is mere hypothesis, and hypotheses have no place in genuine inquiry. This is not false modesty. This is not a gap Newton expected to fill in a later edition. This is a fundamental confession at the heart of his life's work. Newton could describe gravity's effects with perfect mathematical precision. He could not explain its cause, and he was honest enough to say so. Now consider how strange this is. We speak of Newtonian gravity as settled science. We teach Newton's laws as if they revealed the nature of gravitational attraction. We act as though the mystery was solved in 1687. But Newton himself knew better. Newton himself insisted that the mystery remained. The equations work. This is beyond dispute. But working equations do not require understanding of mechanism. Accurate prediction requires only reliable observation of pattern. You can predict the next sunrise without understanding stellar fusion or planetary rotation. You can predict the tides without understanding gravitational influence on water. You can predict projectile motion without knowing what gravity actually is. Correlation is not causation. Description is not explanation. Predictive success is not the same as understanding mechanism. Let me put this even more starkly. Consider the relationship between a circle's circumference and its diameter. This relationship can be stated with perfect precision, the ratio we call p. We can calculate this ratio to 1,000,000,000,000 digits. We can use it to build everything from wheels to telescopes. But does this relationship explain why circles have this property? Does it tell us why p rather than some other number? Does it reveal the mechanism by which circular shapes come to possess this ratio? It does not. Mathematics describes relationships. It does not explain why those relationships hold. This is true of every equation in natural philosophy. The equations capture patterns, sometimes with breathtaking precision. But the patterns themselves remain unexplained. The map, however accurate, tells us nothing about why the territory has the shape it does. Newton understood this. His critics understood it too. Leibniz, that brilliant rival, charged that Newton had reintroduced occult qualities into natural philosophy. A hidden force acting mysteriously at a distance, with no mechanism, no medium, no explanation. A return to scholasticism, Leibniz said. A step backward from genuine understanding. And here is what troubled Newton throughout his working life. Leibniz was not entirely wrong. Newton's equations described gravitational effects as if a force reached across empty space instantaneously to grip distant objects. But how could this be? What medium carried this force? Through what did gravitational influence travel? By what mechanism did the sun, 93 million miles away, hold the Earth in its orbit? Newton had no answer. He could write the equation. He could not describe the reality the equation supposedly represented. The map worked. The territory remained unknown. And so, for more than 2 centuries, this question lay dormant. Physicists used Newton's equations, built upon them, extended them to new domains, while the fundamental mystery remained unexamined, quietly embarrassing to anyone who looked too closely. Everyone agreed that gravity pulls objects toward each other, but no one could describe how. No one could identify the mechanism. The word gravity named the phenomenon. It did not explain it. The map was mistaken for the territory, until someone finally asked the question Newton could not answer. What if gravity as a pulling force is not merely incomplete, but wrong? Newton was troubled, not by doubt about his equations. These he trusted absolutely. The mathematics worked. The predictions proved accurate. The framework unified terrestrial and celestial mechanics as nothing before had done. No, Newton was troubled by what his equations seemed to require. Action, at a distance. How does the sun, separated from this earth by a gulf so vast that light itself requires 8 minutes to traverse it, how does that distant furnace reach across this emptiness to grip our world? Through what medium does this influence travel? By what mechanism does matter at one location know of matter at another and respond to it? These questions haunted Newton, and he was honest enough to admit he could not answer them. In his correspondence with Richard Bentley, Newton confessed his discomfort in terms that should startle anyone who thinks he explained gravity. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Read that again. Newton called action at a distance so great an absurdity that no competent thinker could accept it, yet his own equations required it, or seemed to. Consider what this means. The author of Universal Gravitation the man who unified heaven and earth under a single mathematical law, considered the implications of that law philosophically absurd. He was right to be troubled. Imagine you hold a rope attached to a distant weight. You pull on your end. The weight moves at the other end. The mechanism is clear. Your force travels through the rope, fibre to fibre, tension propagating along its length until it reaches the weight and moves it. Now remove the rope. Could you still move the distant weight by pulling? The suggestion seems absurd. How would you grip it? Through what would your force travel? What would connect you to something you cannot touch? Yet this is precisely what gravity appears to do. The Earth pulls the Moon across 250,000 miles of empty void, with nothing between them. No rope, no rod, no medium of any kind. The Sun pulls the planets across tens or hundreds of millions of miles of vacuum. The attraction seems to operate through nothing. Worse still, Newton's equations treat this influence as instantaneous. If the Sun were to somehow vanish from existence, would the Earth immediately fly off in a straight line? Or would it continue orbiting for 8 minutes, the time light requires to travel from Sun to Earth? Newton's mathematics implied the former, instantaneous action. But how can influence travel faster than anything else in nature? How can the Sun's presence be communicated to the Earth without any delay? What mechanism could possibly operate this way? Newton had no answer. He explicitly refused to speculate. "The cause of gravity is what I do not pretend to know," he wrote. This is the honest position. This is what genuine inquiry looks like. Not fabricated certainty, but acknowledged mystery. Not false mechanism invented to satisfy the mind's craving for explanation, but restraint in the face of the unknown. Newton could have speculated. He could have invented particles, or emanations, or subtle fluids connecting masses. Others did so freely, proposing gravitational mechanisms that satisfied intuition while having no basis in observation. Newton refused. Whatever is not deduced from phenomena is to be called hypothesis, and hypotheses have no place in experimental philosophy. This restraint served understanding well. Precisely because Newton's gravitational law described only what phenomena demonstrated, it remained valid even when deeper understanding emerged. Speculative mechanisms would have required revision or abandonment. Pure description endures, but the puzzle remained. How does gravity work? Through what does its influence propagate? What connects the Sun to the planets, the Earth to the Moon, your body to the floor beneath your feet? For 200 years after Newton's death, these questions lay dormant. Physicists used the equations, celebrated their accuracy, built technologies upon their foundation, and quietly ignored the philosophical absurdity at their heart. Then came a transformation, not a refinement of Newton's picture, not a mechanism to explain the pulling force, something stranger, something that revealed the question itself was wrong. What if gravity is not a force at all? What if gravity is not a pulling force? What if the Moon does not orbit because something pulls it? What if the apple does not fall because something drags it toward the Earth? What if, instead, these objects simply travel the straightest possible paths through a space that is itself curved? This is not metaphor. This is not poetry. This is the actual state of understanding that emerged 2 centuries after Newton's work, and it transforms everything. Consider a ship sailing across the Atlantic. The captain plots what he believes is a straight course, the most direct route from one port to another. He sails this course faithfully, maintaining constant heading. If you trace his path on a flat map, it appears straight. But the Earth is not flat. The Earth is a sphere. Now trace that same path on a globe. The straight line on the flat map becomes a curve, a great circle arc sweeping across the spherical surface. The ship followed a curved path, not because any force bent its course, but because on a curved surface, the straightest possible path is itself curved. This is geometry, not force. The ship responded to the shape of the surface it travelled upon. Now extend this insight to space itself. What if space, the void through which planets move and objects fall, is not flat? What if the presence of mass warps the geometry of the region around it? What if massive objects curve space itself, and other objects simply follow the curves that result? In this picture, the moon does not orbit because the Earth pulls it. The moon travels the straightest available path through a spacetime that has been curved by the Earth's presence. The curved path we observe as orbit is not forced upon the moon. It is the natural trajectory through bent geometry. No pulling required, no action at a distance, no mysterious force reaching across the void, only geometry. Consider what this means for Newton's troubling puzzle. If gravity is not a force, but rather the curvature of space, then nothing reaches across the void from sun to planet. The sun does not pull the Earth. The sun's presence warps the spacetime around it, and the Earth responds to this local warping, the geometry of the region it actually occupies. Each object responds only to its immediate surroundings. Nothing acts at a distance. The philosophical absurdity dissolves. But let me make this tangible. Imagine a marble rolling across a flat surface, a table perhaps. The marble travels in a straight line until it reaches an edge or encounters resistance. Its path is determined by the geometry of the surface. Flat surface, straight path. Now imagine the surface is curved like a bowl. Set the marble rolling along the rim. Without any force pushing it sideways, the marble follows a curved path. The curve is not imposed by force, it is demanded by geometry. On a curved surface, the straightest available path is itself curved. This is what mass does to space. It creates a bowl in the fabric of spacetime. Objects approaching this bowl follow curved paths, not because they are pushed or pulled, but because the geometry they travel through has been warped. The planets orbit the sun, not because the sun grips them with invisible force, but because the sun's mass has curved the spacetime around it, and the planets follow the curves that result. The moon orbits the Earth, not because the Earth pulls it, but because the Earth's mass has warped local spacetime into a shape through which the moon's straightest path is a curve around the Earth. The apple falls not because the Earth attracts it, but because the apple, freed from the branch, follows its natural trajectory through curved spacetime, and that trajectory leads toward the Earth's center. This is a complete reconception, not a refinement of Newton's picture, not a mechanism hidden behind the pulling force, a replacement of the entire framework. In Newton's picture, forces act between objects across empty space. In the geometric picture, no forces act at all. Objects follow curved paths because space itself is curved. These are fundamentally different claims about what exists and what happens. The error most make is assuming this geometric interpretation is merely a different way of describing the same thing, like saying 6 instead of half a dozen. It is not. The mathematics differs. The predictions differ in extreme circumstances. The picture of reality differs profoundly. In one picture, space is passive and flat, and forces somehow reach across it to move objects. In the other picture, space is dynamic and curved, and objects move through it freely, without any force, following the geometry they encounter. The second picture eliminates the absurdity that troubled Newton. Nothing reaches across the void. Nothing acts at a distance. Each object responds only to the local shape of spacetime. But if this is so, if gravity is geometry rather than force, then what about the weight you feel right now? You are not orbiting. You are sitting still. What does the geometric picture say about the heaviness pressing you into your chair? The answer will invert everything you think you know about what it means to feel heavy. You have never felt gravity. The heaviness pressing you toward the floor right now, that is not gravity. What you feel is the floor pushing up against you, preventing you from following your natural path through curved spacetime. This is not wordplay. This is not clever reframing. This is the actual physical situation, and understanding it will transform your perception permanently. Consider what it means to feel something. You feel pressure when something presses against your skin. You feel resistance when something opposes your motion. You feel weight when something prevents you from moving the direction spacetime's geometry demands. But you cannot feel an influence that exerts no pressure, creates no resistance, imposes no contact. Gravity, understood as the curvature of spacetime, is precisely such an influence. It is not a force pressing upon you. It is the shape of the space you move through. You do not feel the curvature of space any more than you feel the curvature of the Earth's surface as you walk. The curvature is there. It affects your path, but it exerts no pressure on your skin. What then do you feel when you feel heavy? You feel the floor. Press your palm against the table. You feel resistance, the table pushing back against your hand, refusing to let your hand pass through it. This sensation is contact. This sensation is real. Now recognize the same sensation constitutes your weight. The floor presses against your feet exactly as the table presses your palm. The chair presses against your back and legs. These are contact forces, solid objects resisting your passage. Remove these contacts and the sensation of weight vanishes. Step off a cliff. For those moments of falling, before air resistance becomes significant, the sensation of weight disappears entirely. You feel nothing pulling you toward the earth. You feel no force acting upon you at all. You are, for those moments, weightless. But gravity has not disappeared. The curvature of spacetime remains. The Earth's mass still warps the geometry around it. What has changed is this. You are no longer being prevented from following your natural path. In free fall, you travel the straightest available path through curved spacetime. Nothing pushes against you. Nothing resists your motion. You experience no force because no force acts upon you. Those we call weightless, astronauts orbiting the Earth, cosmonauts drifting in their capsules, have not escaped gravity. They are still firmly within the Earth's gravitational influence. The spacetime they travel through is still curved by the Earth's mass, but they are in free fall. They follow curved spacetime without interference. Nothing pushes against them, and so they feel no weight. Weight is not gravity pulling down. Weight is resistance to natural motion. Weight is the floor refusing to let you fall. Consider the equivalence this implies. Imagine yourself in a windowless chamber. You feel weight pressing you toward the floor. How do you know whether this weight comes from gravity, the chamber, resting on Earth's surface, or from acceleration, the chamber being pushed upward through empty space, like a lift ascending? You cannot know. The sensations are identical. If the chamber is at rest on Earth's surface, the floor presses up against you, resisting your natural fall through curved spacetime. You feel weight. If the chamber is accelerating upward through empty space, the floor presses up against you, imparting acceleration to your body. You feel weight. The two situations produce the same sensation because they are, in the geometric picture, the same phenomenon, a surface pressing against you. This equivalence is not a curiosity. It is the key that unlocked the geometric understanding of gravity. The fact that gravitational weight and accelerational weight are indistinguishable pointed directly toward the conclusion that gravity is not a force but a feature of space-time geometry. And now the common understanding inverts entirely. You stand on the ground. You feel heavy. You believe gravity pulls you down and the floor merely supports you, counteracting the downward pull. But here is what is actually happening. You, freed from all contact, would follow your natural path through curved space-time, a path that leads toward the Earth's center. The floor, held rigid by forces within its material, cannot follow this path. The floor is perpetually accelerating outward through space-time, refusing to fall. The floor pushes up. You feel this push as weight. Gravity does not pull you down. The floor pushes you up. What you feel is entirely the floor's doing. Notice the sensations in your body right now. Your feet against the floor. Your back against the chair. Your arms resting on solid surface. These are the sources of your weight, these contacts, these resistances, these refusals to let you fall. Remove them all, and weight vanishes. Not because gravity disappears, but because nothing pushes against you. Now stand. Feel the floor beneath your feet pressing upward. Walk across the room and feel the floor continuously pushing up, step after step, refusing to let you follow spacetime's curved path toward the Earth's center. You have never felt gravity. You have only ever felt the floor. And that changes everything. Watch an apple fall. You have seen this 1,000 times. The stem breaks, the fruit detaches, and the apple accelerates toward the ground. Impact. The apple lies still. You nod. Gravity has done its work. But you have not seen what actually happened. The apple did not fall. From the geometric perspective we have now established, here is the true account of events. The apple, detached from its branch, is suddenly free. No force holds it in place. It begins to move along the straightest available path through the spacetime warped by Earth's mass. This path curves toward the Earth's center, not because anything pulls the apple, but because this is the geometry of the region. The apple follows this path freely, experiencing no force whatsoever. In its own frame of reference, the apple is weightless. The apple is at rest. Meanwhile, the Earth's surface is doing something remarkable. The ground cannot follow spacetime's curvature. The atomic bonds within rock and soil and pavement hold the surface rigid, preventing it from collapsing toward the Earth's center. These bonds exert force, real, measurable force, that accelerates the surface outward through spacetime. The ground is accelerating upward, perpetually, everywhere, and so the apple, following its natural inertial path, and the ground, accelerating upward to maintain its position, converge. They meet. Impact occurs not because the apple was pulled down, but because the ground rose up. The apple did not fall to meet the ground. The ground rose to meet the apple. This is not metaphor. This is not a trick of perspective. This is what the geometric understanding of gravity actually describes. The mathematics differs from Newton's picture. The physical account differs. The causal story differs. In Newton's picture, the Earth exerts force on the apple, causing the apple to accelerate downward. The ground merely receives the falling object. In the geometric picture, no force acts on the apple. The apple moves freely through curved space. The ground, held rigid by internal forces, accelerates upward through spacetime. Collision occurs when these two trajectories intersect. Consider the implications. Every object you have ever watched fall was actually moving freely. The dropped stone, the tumbling leaf, the spilled water, all of these were in free fall, experiencing no force, following the natural geometry of curved spacetime, weightless, unforced, at rest in their own frames. It is we, attached to the accelerating surface, who observe their approach. It is we who are being pushed. The falling objects are merely drifting. We are the ones undergoing acceleration. When you catch a falling ball, you feel the impact because your hands connected to your body, which is connected to the accelerating floor, suddenly resist the ball's natural motion. You impose force on the ball, stopping its free drift through space-time. The ball exerts force on your hands in return. This is the impact you feel. But while the ball was falling, no force acted on it. It was you, not the ball, who experienced continuous force, the floor pressing up, accelerating you through space-time, preparing you to intercept the drifting ball. The error most make is thinking this is mere wordplay, redescribing falling down as floor rising up without changing anything substantial. It is not wordplay. In one description, forces act on falling objects. In the other, no force acts on them at all. These are genuinely different physical claims. An accelerometer attached to a falling object reads 0, no acceleration detected, no force measured. The same accelerometer resting on a table reads 1g, continuous acceleration upward, force measured. The instruments agree with the geometric picture. Falling objects experience no force. Resting objects experience continuous force from the surfaces that support them. You can verify this yourself. Hold an object at arm's length. Feel its weight, the object pressing down on your palm, because your palm, connected to the accelerating floor through your body, is pressing up on the object. Now release it. The object enters free fall. If you could measure the forces acting on it during descent, you would find none. 0. The object experiences nothing until the floor intercepts it. The floor did not catch a falling object. The floor rose to collide with a drifting one. Now look around you. Every object resting on a surface is being pushed upward by that surface. Every table, every chair, every stone lying on the ground, all are experiencing continuous upward force from the surfaces beneath them. All are being accelerated through space-time, prevented from following their natural paths toward the Earth's center. And you, sitting or standing, reading or listening, you too are being pushed. The floor presses your feet. The chair presses your back. These surfaces, rigid with internal forces, refuse to let you drift along space-time's curvature. They accelerate you outward, perpetually, relentlessly. You feel this acceleration as weight. You have been feeling it your entire life. You called it gravity pulling down. It was always the floor pushing up. The apple never fell. The ground rose. And everything you thought you understood about falling objects has been inverted. But if this geometric principle governs the apple's brief descent, does it also govern the moon's eternal orbit? Can the same understanding that transforms our perception of falling transform our perception of the heavens? It can, and it must, for this is the unity that lies at the heart of genuine understanding, one principle governing all, from the fruit that drops in an orchard to the celestial bodies that wheel through the void. Look at the moon tonight. It hangs in the sky, serene and silver, tracing its ancient path around our world. It has followed this path since before humanity existed. It will continue for aeons after we are gone, eternal, unchanging, celestial. And it is falling. The moon is falling toward the Earth right now. It has been falling for 4,000 million years. It will continue falling for thousands of millions more. But it keeps missing. This is orbit. This is the cosmic dance we observe when we watch the planets wheel around the sun, when we see satellites cross the night sky, when we track the moon through its monthly phases. Perpetual fall, eternal, near miss, geometry in motion. Let me show you how this works. Imagine yourself atop a mountain, the highest mountain in the world, rising above the thickest of the atmosphere. You have a cannon. You point it horizontally, parallel to the Earth's surface, and fire. The cannonball emerges and immediately begins to fall. Follows a curved path, descending toward the Earth while also travelling forward. After a certain distance, it strikes the ground. Now imagine you fire the cannon harder. The ball emerges faster. It travels further before falling the same vertical distance because it moves horizontally faster while falling at the same rate. It lands further from the mountain. Fire harder still. The ball travels even further, faster and further, faster and further. At some point, something remarkable happens. The ball is travelling so fast horizontally that as it falls, the curved surface of the Earth curves away beneath it at the same rate. The ball falls, but the ground recedes. The ball falls further, and the ground curves further away. The ball never reaches the surface. It falls forever. This is orbit. No force holds the cannonball in its path. No invisible hand grips it and prevents its escape. The ball simply falls, perpetually, while moving fast enough sideways that it continuously misses the planet beneath it. The moon is this cannonball. Long ago, the moon acquired sideways motion, motion tangent to the Earth, motion that carries it around rather than toward, and it began to fall. It has been falling ever since, but its sideways motion is fast enough that as it falls toward Earth, the Earth's curved surface curves away beneath it at the same rate, falling and missing forever. In the geometric picture, this becomes even clearer. The moon follows the straightest available path through spacetime curved by Earth's mass. This path happens to loop around the Earth, not because the moon is being pulled in a circle, but because spacetime's curvature in this region admits no straight paths. The straightest path available is a curve. The moon follows it freely, experiencing no force. The moon is weightless. Think about that. The moon, massive as it is, experiences no gravitational force. It follows curved spacetime without resistance. Nothing pushes against it. Nothing accelerates it. It drifts freely along the geometry of bent space, and that free drift carries it around the Earth perpetually for billions of years. This is the unity of heaven and earth. The apple falls briefly. The moon falls forever. Both are doing the same thing, moving freely through curved spacetime. Only the initial conditions differ. The apple starts at rest relative to the ground. The moon starts with enormous sideways velocity. But the principle is identical. The same geometry that brings apple to ground holds moon in orbit. This uniformity cannot be accident. Before Newton, the celestial and terrestrial realms were thought to obey different laws. The heavens were perfect and eternal, governed by principles unknown on corruptible earth. The fall of stones and the circuit of planets seemed entirely different phenomena. Newton unified them under a single mathematical law. The same equations that describe apples describe moons. The geometric picture deepens this unity. Not only do the same equations apply, the same physical process operates. Free motion through curved spacetime. No forces in either case. No pulling, no gripping. No action at a distance, only geometry. The ancient distinction between earthly and heavenly physics dissolves completely. Watch the moon rise tonight. See it not as something held in orbit by gravitational grip, but as something falling freely, weightlessly, along the curved space-time that Earth's mass creates. It has been falling since before life existed. It will fall until the sun swells and consumes us all, falling and missing forever. And every satellite you see crossing the night sky, every piece of machinery humanity has hurled into orbit participates in the same ancient dance, falling toward the earth, missing the earth perpetually. The moon that rises tonight is your companion in free fall. The geometry that curves your path toward the earth's center also curves its path around the earth entire. One principle governs all. This is the unity. This is the elegance. This is what Newton glimpsed in his equations, but could not fully explain: the profound simplicity underlying apparent complexity, the single truth that manifests in countless forms. And now, a question presses. We have traced gravity from misconception through geometry to cosmic unity. We have seen the pulling force dissolve into curved spacetime, the falling object revealed as freely drifting, the orbiting moon understood as perpetually missing. But if gravity is geometry, if mass curves spacetime and objects follow the curves, then why does mass curve spacetime? What is the mechanism behind the mechanism? We have answered one mystery. Have we only uncovered a deeper one? You might believe you now understand gravity. You have learned that the common picture is wrong, that gravity is not a pulling force reaching across empty space. You have seen the geometric alternative. Mass curves spacetime. Objects follow curved paths. You have felt the inversion of weight, perceived the unity of apple and moon, grasped the elegant simplicity underlying apparent complexity. And you might believe the mystery is solved. It is not. The mystery has transformed. It has not vanished. Consider what we have established. Mass curves spacetime. The presence of matter warps the geometry of the region around it. Objects respond to this warping by following curved paths. Now pause at that first statement. Mass curves spacetime. How? By what mechanism does a lump of matter alter the geometry of the space around it? Through what process does the presence of stuff warp the fabric of existence? What mediates between mass and geometry? These questions have no answer. The equations describe the relationship between mass and spacetime curvature with extraordinary precision. Given the distribution of mass, the equations predict exactly how spacetime will curve. Given the curvature, the equations predict exactly how objects will move. The mathematics works flawlessly, but the mathematics does not explain why this relationship exists. This is Newton's position all over again, but at a deeper level. Newton gave us equations that describe gravitational effects without explaining the mechanism. We have now gone deeper. Space-time geometry underlies gravitational effects, but the relationship between mass and geometry is itself unexplained. We have pushed the mystery back a step. We have not dissolved it. Why does mass curve space-time? How does matter know to warp geometry? What is space-time itself, that it can be bent and rippled and twisted by the presence of stuff? These questions remain open. Perhaps you feel disappointed. You came seeking understanding and have found only transformed mystery. The comfortable fiction of gravity pulls things down has been demolished, and what replaces it is stranger and ultimately no less mysterious. But this disappointment is itself a mistake, a failure to grasp what genuine inquiry actually offers. The universe is not a puzzle to be solved. It is a mystery to be explored without end. Every answer reveals deeper questions. Every solution exposes stranger puzzles. This is not failure. This is the authentic condition of honest inquiry. Consider the pattern. Newton described gravity's effects without explaining its cause. His intellectual integrity lay in admitting this limitation. Reframed no hypotheses. He gave us description without fabricated mechanism. Einstein reframed gravity as geometry. His intellectual achievement lay in dissolving one mystery, action at a distance, by revealing a deeper structure. But the deeper structure is itself unexplained. Future investigators will probe the relationship between mass and geometry. Perhaps they will find some still deeper principle that explains why matter warps spacetime. But that principle, whatever it is, will rest on assumptions that themselves demand explanation. The tower of understanding descends into mystery at every level. Imagine you fully understood why mass curves spacetime. Your explanation would invoke deeper concepts, perhaps the fundamental nature of mass, or the quantum structure of spacetime at scales too small to observe. You would explain mass geometry interaction in terms of these deeper concepts. But then, why do those deeper concepts hold? What explains them? Every explanation requires assumptions. Every foundation rests on further foundations. At some point, we reach bedrock that cannot be explained further, or we discover that there is no bedrock at all, only turtles all the way down. This might seem cause for despair. If understanding never completes, if mystery always lurks beneath explanation, what is the value of inquiry at all? The value is this: description without fabrication, accurate maps of territories we cannot fully comprehend, predictions that work even when mechanisms remain hidden, utility and beauty and truth within limits. Newton's equations work. They predict planetary motions for millennia. They guide spacecraft across the solar system. They operate reliably regardless of whether we understand the ultimate nature of gravity. Einstein's geometric framework works better still. Accurate where Newton's approximation fails, precise in extreme conditions, verified by experiments Newton could not have imagined. And it works regardless of whether we understand why mass curves spacetime. Understanding need not be complete to be valuable. Maps need not depict territories perfectly to guide us through them. Explanation need not reach ultimate bedrock to illuminate the world we inhabit. This is the honest stance of inquiry. Confident description combined with humble acknowledgement of ignorance. I can tell you what happens. I cannot tell you why. This confession does not diminish achievement. It defines it. It sets boundaries honestly. It leaves space for future discovery rather than closing inquiry with fabricated certainty. Newton modelled this stance. The cause of gravity is what I do not pretend to know. Einstein modelled it too. His equations describe mass geometry relations. They do not explain them. And we, having traced gravity from misconception through revelation to deepened mystery, can model it as well. The mystery has not been solved. It has been transformed into something stranger and more wonderful. This is not failure. This is the ocean. Picture a child playing where ocean meets land. The tide has receded, leaving treasures scattered along the waterline. Shells and pebbles lie everywhere, some smooth and lustrous, some rough and ordinary, some strange enough to make the child stop and stare. Each discovery brings delight. Each treasure gets examined, turned over, held up to the light. But the child also sees the ocean. It stretches to the horizon and beyond, grey-green and infinite, filled with depths unexplored and wonders unimagined. The pebbles on the shore are real discoveries, beautiful, precious, worthy of attention. But they are not the ocean. They are what the ocean has offered up. The vastness remains. This is the authentic condition of inquiry into nature's deepest principles. We have found pebbles, beautiful ones. We have learned that gravity is a name, not an explanation, that the word silences questions rather than answering them. We have seen that mathematical description differs from physical explanation, that equations can work perfectly while mechanisms remain unknown. We have confronted the puzzle that troubled Newton himself. Action at a distance, influence through nothing, philosophical absurdity at the heart of his greatest work. And we have seen that puzzle dissolve. Gravity is not a pulling force. Space itself is curved by the presence of mass, and objects follow the curves that result. The moon does not orbit because something grips it. It falls freely through bent geometry, missing the Earth forever. The apple does not fall because something pulls it. It drifts along spacetime's curvature, while the ground rises to meet it. Weight is not gravity acting on you. It is the floor's refusal to let you follow your natural path. These are genuine insights. These are smoother pebbles, prettier shells than ordinary. These transform how you perceive the world you inhabit. But the ocean remains. Why does mass curve spacetime? What is spacetime itself? What deeper principles, if any, explain the relationship between matter and geometry? These questions are open. Perhaps they will be answered by investigators not yet born, working with mathematics not yet developed, building instruments not yet imagined. Perhaps the answers will reveal still deeper questions, still stranger mysteries, still vaster oceans. This is not frustration. This is invitation. The mark of a truly curious mind is not the answers it possesses, but the questions it refuses to abandon. We have journeyed through gravity, from comfortable illusion through productive confusion to transformed understanding. What remains is not conclusion, but beginning. Here is what you can carry forward. When someone offers an explanation, test it. Can they describe the mechanism, or have they merely named the phenomenon? Does their account reveal how causes produce effects, or does it simply label observations? The naming fallacy operates everywhere, in science, in medicine, in economics, in daily life. Learn to detect it. When equations work perfectly, do not assume the underlying reality is understood. Maps can be accurate without depicting the territory truly. Predictions can succeed without mechanism being grasped. Correlation is not causation. Description is not explanation. When you feel satisfied with your understanding, when you believe you have figured it out, probe deeper. What assumptions does your understanding rest upon? What explains those assumptions? Every foundation stands on further foundations. Comfortable certainty is usually premature. And when you reach the limits of understanding, when questions arise that you cannot answer, do not fabricate certainty. Let the mystery stand open. Admitted ignorance is the door through which new knowledge enters. Premature closure locks that door. These principles govern all honest inquiry. They are pebbles of genuine value, applicable far beyond the topic that revealed them. Now, go outside tonight, if the sky is clear. Feel your weight, the floor pressing up against you, preventing your natural fall through curved spacetime. You are not being pulled down. You are being pushed up. The sensation you have felt every moment of your life is not what you thought it was. Watch the moon, if it has risen, if clouds permit. See it falling toward you, as it has fallen since before life began, as it will fall until the sun consumes us. Falling and missing, forever. The same geometry that governs the pebble dropped from your hand governs that ancient silver sphere. Consider the stars, distant suns, each warping the space-time around it, each holding planets in perpetual fall, each participating in the same geometric dance that defines our solar system. The universe operates by principles you have only begun to perceive and feel wonder. Not because the mystery is solved, it is not. Not because you now possess final truth, you do not. But because you have glimpsed something real. You have seen through the comfortable illusion to the stranger reality beneath. You have asked questions most people stop asking in childhood, and you have found that the questions lead somewhere remarkable. The great ocean of truth lies all undiscovered before us. What we have found are pebbles on an infinite shore, smoother and prettier than ordinary, perhaps, but pebbles still. The ocean stretches beyond horizon, beyond imagination, beyond any single lifetime's exploration. You have learned that gravity is not what you thought. You have learned that Newton himself confessed ignorance about what gravity is. You have learned that space itself bends and warps, that falling objects move freely while surfaces accelerate to meet them, that the moon has been falling for 4 billion years without ever landing. And you have learned that even this transformed understanding rests on deeper mysteries, that every answer opens new questions, that the tower of knowledge descends into foundations we cannot yet see. This is not cause for despair. The pebbles are real. The beauty is real. The utility is real. We can predict eclipses for millennia, guide spacecraft to distant planets, understand phenomena our ancestors could only marvel at. These achievements matter, even though, especially because they emerge from honest confession of what remains unknown. The universe is not what you thought it was. Gravity is not what you thought it was. The very space you move through bends and curves around the matter within it. You will feel your weight differently now, the floor's resistance, not gravity's pull. You will watch falling objects differently, free motion through curved spacetime, not pulled descent. You will see the moon differently, falling forever, missing forever, the same geometry that governs every plummeting stone. And you will hold all knowledge differently, as pebbles on an infinite shore, beautiful and precious, but never mistaken for the ocean itself. The great ocean of truth lies all undiscovered before us. This is not ending. This is invitation. Go, wander. The ocean is calling.